Hello, everybody. Good morning, good evening, good afternoon, and very warm welcome, at least if you are in Europe sweating away, to everybody joining this Neo4j Live episode. Today, the topic is AI Governor, Quality Gates for Agentic Workflows, and I'm super happy to have my colleague Julian join me. Hi, Julian. How are you doing today? Is it as hot where you are as where I am?
No, not nearly as hot. I'm actually based at Denver, Colorado, so a little bit hot this summer, but not nearly as hot as it is in Europe.
All right, good for you.
Thanks for having me, Alex. Great to see you.
So happy to have you. It's so fun. Just quickly, Ravid, in the YouTube comments said turn on live caption. I think that should be on. I think by default. If not, then well, I think I'm out of luck here, but I think it's on. I hope you should see it. Otherwise, let me know. Yeah, cool. All right. So this is live. Obviously, we'll dive into this AI governor. Maybe before we do so, obviously, I wanted to encourage you all to ask questions, to let us know what you think, what you build. If you're building AI agents, if you need a governor for your agents, maybe let us know your previous experiences. Maybe you have done something similar. Maybe you've had some bad experiences also. Maybe this episode today can help you a little bit. Yeah, before diving into the meat, I would, Julian, maybe if you could share a few words, who you are and what you do, and then we go into AI governor.
Yeah, that sounds great. Thanks, Alex, and thank you everyone for joining. So yeah, quick intro here. My name's Julian Bush. I'm a product-led growth marketer at Neo4j. So I think it gives a little bit of a different perspective. So before AI, not very technical. I really built a lot with product management teams and getting teams together. But the most important thing about product-led growth is taking data from our production apps and getting them in high quality to our customers with triggers and activation signals. And once AI came out and ChatGPT first started, I realized wow, this is really cool. I'm geeking out. How do I go deeper into this? And really just went really deep into orchestration runs and multi-agent orchestration. And previous to Neo4j, I was at MongoDB for about 4 years, where started there and started to realize that, hey, I'm really hitting limitations when it came to the infrastructure that I was using. And I got really excited about Neo4j because I had tested it out with this kind of multi-agent orchestration, and it just was like using a Ferrari instead of a Honda. And I was like, wow, okay, cool. This is really, really cool. And was fortunate enough to come over. And since then, I've only been trying to use and leverage LLMs for production, building semantic layers. Like, how can I use LLMs every day in my work? And have gotten to a point now where I'm really just running with an LLM or an IDE. So share more about the AI governor. And one last step. And what we're talking about today is been one of my personal passions. I think everyone here has probably faced it if they're building with agents. Is they tend to like to lie and say that they've done most of the work, right? And usually it's about 80% complete, or they miss something. So context, decision tracing, and state is just really important. So this governors and this guard and this agent really help me to start to become more repeatable and understand decision tracing and understanding Neo4j's capability when it comes to that stuff. So excited to kind of share what I learned over the past 2 years and share how I use LLMs in production today.
Yeah, I think that should be very interesting, very insightful. I was at MLCon Munich yesterday, and we were talking to many people, and they all had what you just only echo what we just described. Is everybody is interested? Everybody builds stuff with AI. Everybody goes to some degree into agents, but everybody is hesitant about the quality of what they're getting. Everybody sees, okay, it's great. It's getting me from, like you said, from 0 to 8 or even 9 in a super quick time. And then they realize, oh wow, but now I have to look and check all of that, and have to govern all of that, and have to make sure that everything that I've built is now actually doing the things I thought it would be doing, because it might just not.
No, absolutely. Can't tell you that enough. And it's one of my personal pains. And being in product-led growth, I like to be very accurate with what I do. So
yeah,
I get frustrated all the time, and frustrated to the point where I just like went back to first principles. Like, I'm just going to try to figure this out and to start at using LLMs as almost like a user and asking them questions like, how do you self-review this chat, review your own chat, and then start to fine tune and create structure around it. So I'm happy that people are facing the same issues that I did.
Yes, definitely. Cool. I think you outlined a little bit why or how you get to it. Maybe if you could get us a little inspiration about information about the inspiration of how AI Governor came to be. What did ultimately, as a non-developer, kind of, I think it would be very interesting to see, okay, what sparked you say, okay, I'm fed up with all of this. I can do it myself. I can do it better myself. And I get what I want from a project like this.
Yeah, good question. So I would say like most typical users, when ChatGPT first came out, like ChatGPT 3, I was trying to figure out how can I take one chat session and be able to not lose my history or my context from one chat to the next one, and was just iterating, testing, and trying to figure out, hey, what if my agent actually, before it finished and I started to realize the chat session was diminishing, wrote me a prompt of the previous chat, and I could transfer that over to a new chat per se. Try to like go chat from chat, and then all of a sudden I was like, there's still a ton of bias. And then so I was like, what if I had another chat or a prompt or an MD file for a reviewer review kind of the work of the previous agent? And I was like, that's kind of getting like a little bit more seamless. And then I started to really be like, okay, prompting is really tough. I don't want to spend this much time writing out a prompt. How can I get an agent to write a prompt? Naturally, that led to more orchestration. So when you think about kind of like the early loop of what most users go down, it's like, hey, for me, I was becoming lazy. I was like, I don't want to write these long prompts perfectly the way that they're saying. So I was like, what if I just have an LLM kind of build a role or a personality that writes these prompts? And then it naturally became an orchestrator, which is like that role is not going to be a builder. It's going to be like a director, composer, or a musician that like really builds and scales these projects and breaks them down for the execution agents to like actually perform perfect work with perfect context. And then after that, I was like, okay, now it seems like everything's working, but I can't figure out what the heck they're actually doing. It's like a black.
Yeah.
Like if you're using an IDE, it's tough. So I was like, how do I get this out of the IDE and start to like learn a little bit more about what agents are doing? And that naturally led to me having like this governor, which was like, okay, I want to make sure that all of the agents are performing almost steps before a transition between, different states to like checkpoints. So going through each checkpoint to make sure that like, hey, your context is within a certain limit, pass fail checkpoints, and then letting that go and fine tuning. And then I was mostly file based, like in repo, having like my own personal knowledge base of like every project that I'd done. And it started to get to this thing where it started to become like really big and file bloaty. And I had this big historical files in my repo, which naturally I was like, hey, a database might be interesting here. And tried NoSQL, tried Postgres. And when it came to like the multi-agent orchestration of picking roles and policies and context and compiling them at the same time, Neo4j just like was so good at that. If you start to think about nodes being policies, handoffs, task, date, and then you compile them at cold start, and all of a sudden you're basically running multi-agent orchestration with governance as well, which is a little bit what I'm going to show today with the system.
Cool. And I think you show that, but I think the idea was for you then to build something that can be inserted in any kind of workflow with the way it's set up. So you have, it works for you, but it will work for anybody else, because it's just this almost plug and play like concept. I guess you wanted to make it easy for you to adapt to changes, but was your goal to? Did other people talk to you and say, I know I want this too, and can you share this with me, because you had something almost ready and thought, okay, well, might as well make it in a way that everybody can adopt it and use it.
Exactly. Yeah. Like it. So William, Will Lyon on our team was like, this is really good for Julian. We know that you're getting a ton of output, and we know that this is awesome, but like, how do we get this into users to like use themselves? And it can be, outside of my typical Julian productivity loop and stuff like that. So naturally, like the first step for me was the most impactful kind of productivity output for using LLMs in production was making sure that they're doing quality work. Like once you kind of build that structure and that layer, you can really build anything on top of it, because you've kind of figured out that like, okay, this is when they don't perform. This is when, they're missing, their work, or this role is, and this policy isn't working, at the same rates as someone else. So you start to fine tune, but until you have that like muscle memory of validating agent work and quality and all these different things, and building that knowledge base of what quality looks like for these agents when performing work, like it's really hard to build like any type of orchestration layer on top of it, because agents will continuously not know what success looks like. So almost building that early validation of like governance, what does quality look like, and decision tracing only makes the foundation super hard and scalable.
Cool. Yeah, that makes a lot of sense. All right. Let's look into it. Again, I see Diego in chat definitely has some questions. Excited to be here. Thank you for joining. So yeah, again, if you have questions, just put them in chat. We'll have some time at the end to answer them. So just don't be shy.
Well, I'll start. I can share my screen. Kind of what I was thinking for today was running through like a high level overview.
Exactly. Yeah, that would be cool. Yeah.
And then we'll jump in the demo. Cool.
Yeah, sounds good.
So let me share my screen. Perfect. Can you all see that?
That should work. Yes.
Great. Okay. So yeah, as I talked a little bit about intro here, but first kind of step here is kind of the validation here. Question I like to ask is like, can you actually reproduce every single decision trace, every single action, every why that your agents performed in the past? This is just a snapshot of the past 30 days of using my system. So if you look at this, what you're seeing is like out of the tasks. So these are actual tasks that agents have done. There's been 487. The average governor score, which we'll talk about in a second, was around an 89 out of 100. And why that we do those thresholds, I'll tell you a little bit more about the scoring in the later slides. And then reworked. So one of the key things here is creating the automation that when an agent doesn't perform work correctly, can you create a handoff from that bad work and have the agent redo its work to get to a higher rate, so that you always have perfect work through each iteration. Even if they don't get to the 100% quality, you want to make sure that they're at least completing all their work. And then governed, let me go back. So 99.8. So when I did this query, it was there's one running in between. It should be 100%, but it's 99.8%. So every one of my tasks, every one of my decisions has always had an agent govern its work and make sure it has performed everything that it was told to do. And if not, it's been reworked by another agent to get to 100%. And then the work, you can kind of see it split between implementation and deploy. So real code changes, investigation and audits, as well as some maintenance work, which is just like audits on top of like production systems.
And that's the percentage of how many, the 76% out of all of the work you put into it all the tasks to put in were delivery tasks. It's not the scoring of each of those. So
yeah. So normal, just like if you think about it, like a task completed in one chat session, one objective with success that was completed in one chat session, rated at that rate, and then the second chat session has the governor review the work. So it's almost 2 agents back to back, multi-hand. Good question. Yeah, so the whole infrastructure that I'm using here and what I've built here is really just an IDE. So I like to think of the IDE as almost the UI. It's the front edge on top of Aura, on top of my semantic layer, which I have all of my knowledge base of history, all the work done, all the agent work that's done. So it's almost like my agentic co-pilot semantic layer of a knowledge base of all my work that you can create. And then lastly, code, like all the repos, all the files, all the workflows that you do can all be in Neo4j. So little hint that I always like to say is I need code. So if you think about it, if you're working on 10 different repos, 10 different projects, those can be system nodes with a mount or a link so that your agents can find it. And then you can have a full tree on top of it. So you almost have this semantic layer on top where it's like, how does work get done? And then underneath that, it's almost like, where is the work live and what does the work provide? Is really how this system works today and how I'm running it in production.
Cool. Yeah.
Oops. So yeah, we talked a little bit about this, Alex, but so what does work looks finished? I think we see this all the time. And if you don't have this backbone of like how to complete work, you're always going to think agents tend to bias towards what you like. So they're going to say, oh, this is finished, it's complete. But when you actually have someone validate it or an agent validate or even yourself validate, you'll realize like maybe there's a ton of extra code that's like irrelevant, tech debt. It looks finished, but they went off on a tangent to fix a different problem. All this stuff that like drives me insane. Probably drives a lot of people insane.
I think it does.
So hopefully what I show you today kind of helps to ingrain some of those techniques and hopefully lessen the amount of time that everyone here has to spend chasing down what their agents did and then also optimize it. But the memory of why I think is really important. So when something goes wrong, especially like in production system, there's really no way for you to check what was the reasoning behind it. What was there a rollback? What was the Git difference? Like what happened per se? And that's really hard when you're trying to hook up an IDE to like your real important systems or don't have this type of decision tracing or semantic layer to understand which agent, what role, what policy, what handoff led to this incident. And with Neo4j, it's literally just one simple cipher that's a multi-hop traversal that pulls in exactly what happened on that date to figure out what happens. And that's what really makes Neo4j impactful, is because the relationships become the edges of why work was done.
Yeah, and that is super important. At the conference, I heard a session from somebody who's doing all kinds of coding with LLMs, and they were saying that the LLM is trained at a certain state, obviously, as we all know, and then something changed in the documentation or in the APIs or in some tools have switched and they were now used differently than before. And so the LLM goes in and thinks, okay, I know how this is done. I know I have the docs, I have everything is available, and executes, and then gets a failure because it's changed and it doesn't know why. So it tries and it goes around and all these things, and tokens go up, so everything goes crazy. And then in the end you look back and think, okay, yeah, it comes back and says, well, it's done now. Obviously nothing works. It's made up something completely new that doesn't really go in line with anything, and then you think, okay, what's happened here? And
I mean, even if you saw from my first slide, I mean, I have this whole entire architecture system to track this stuff, and even with all this architecture and all this governance, 1 in 4 execution runs don't hit quality and have to be reworked. Like that's just like a huge red flag that like, hey, everyone out there really needs to understand that not only are these LLMs not as accurate as you think they're going to be, but they also have a ton of bias. So unless you really put this review and checks and governance in there and really decision traces, it's a black box. And I personally, working on this app for like two years, it scares me when LLMs go into production without some type of governance or decision tracing. So I think it's really important, especially as you make the transition enterprise.
Yep.
Cool. So big thing here is this is definitely graph and not RAG what I'm going to show you today. So when I say agents in memory in the same sentence, a lot of people here are definitely thinking about, RAG, retrieval, augmented generation, vectors, embeddings. So this is definitely not RAG. Typically with RAG, you take a pile of documents, you got document intelligence or memory, which is really good for single agent executions for a specific, role type. So if I have like a data analyst agent and I need to have, query or understand the data landscape of GCP for my enterprise client, like that's really good for memory. So this is something else where it's like, it's really the semantic layer on top. It's really more of decisions being nodes and then the whys being edges. So really any type of decision trace is just really either like a 2 or 3 multi-hop trace away, or when you compile some of these contexts together, it's really one hop just compiles of the context needed for the agents at cold start. So that's what makes Neo4j really, really interesting here. And then this is definitely not recall. Like with RAG, it's mostly you're recalling at the time it happens or one tool call. It's definitely part of the tool suite. And there is some RAG capabilities in this MCP. So like with context bundles, agents do get the most similar handoff at cold start that is similar to their task type and then based on score. So there are kind of like these vector embeddings and RAG types for like context bundles, but really this is just a semantic layer on top where we're pulling in and using graph for its capabilities for relationships and nodes. Okay, so this is kind of a high level overview and apologies for my LLM making this really low quality airplane and person, but I like to I like to talk make this metaphor of like almost TSA or airports, airport security,
Yes, okay.
right? So think about guards as like TSA between the agents when their status in a node or their task in the node is active, right? And they want to change the status or transition the status using the transition engine, Python in the repo, from active to actually the governor reviewing, which would pull in the governor agent. So like the handoff. In order to even get through that status change, they have to go through all of these checkpoints first. So if they run the transition engine tool, any one of these that is not completed will fail and provide a hint back to the agent. So they don't have to stop what they're doing in run. And in the context, they actually get like, hey, you forgot to do a self-review. Make sure that you put your self-review in the node and attach it by the relationship. Or, you forgot to do a rollback with a deploy. And real quick, these EGs might be a little bit confusing. Executor guards. So the execution agent, the orchestrator hands off to the execution agent, changes it from pending to active in the status. The execution agent picks up the handoff, does the work, gets the context, gets the bundle, and then does all the work and begins to try to, change the status from active to ready to governor. And that's when they start going through these checkpoints, right? Yeah. And so anytime they try to transition it, if they don't have all of the right state mechanics or the stuff that they're doing in the node or, deliverables attached, all these different things, you can make these whatever you want. They're really can work for anything. But in order to get to where they need to go, they need to actually go through all these checkpoints. And unless they're all pass and all green, that's when the transition can actually run and change the transition step. So it's almost blockers for the agent to understand what good looks like.
Oh, cool. And they would, as you said, with memory, they would store each of these runs basically as a separate run. So you could look back in history and could think, okay, this was successful, or this was stopped here, or this failed there, to compare maybe, or to look back into, copy similar runs maybe, or do something like, okay, in the past this was working, why isn't it not working anymore? Maybe something was changed or something like that.
What you're bringing up is so GDS, you can use a lot of GDS algorithms on this in order for the orchestrator agent to actually understand, hey, this is the good pathway for this type of task.
Yeah, exactly. Yeah.
So like, that's where you start getting into this. And right now we don't really have like a scoring method to like, for the agents to look like, oh, okay, like this is what good looks like and all these different things. But yeah, 100% Alex, like that's kind of the real kicker, and where graph and the semantic layer even gets better. So the more runs, the more projects, the more workflows that you do, man, I'm just one person on this thing. So I can if it soups up and there's more projects and all these different things. So I think that's what gets me excited about Neo4j is watching what people take with this governance and run with and build on top of it. And when I say these guards can be anything, I mean, it could be guards for, a life science company, and they have checks that they need to do before the transition status from like research. They need to make sure that like every scientific document, it has like scientific references. Like just these check guards. So every time before the status changes, you're making your agent follow the state that's needed to progress.
Have you defined these step guards or these guardrails to some extent, or is there is this another? Yeah.
I have, so at the end, if people want to see kind of what my guards are today, I have some appendix slides with like all of my executor guards, what kind of they are today, my orchestrator guards, what they're today, temporal guards, and then the governor score too. And we can spend a little bit of time for sure. I can run through those.
Okay. Yep.
That's awesome. But this next step here is kind of the layout of what that life cycle looks. So 5 families, 1 life cycle. So as I was talking about before, the orchestrator is not the execution. It's a musical composer. It really plans what the project plan is going to look like. And think, if you've ever heard the metaphor, you've got to take one bite out of the elephant, right? Can't do the whole elephant in one run. Like I think that we think that LLMs can do an entire project in one context, and that to me just like scares me.
Yeah.
So what if you I guess my thesis here would be like, think about it the opposite way. Like, what if you just took one bite of the elephant, under 200K of context windows, and how many bites of that elephant would it take you to get to a perfect completed project? So that's what the orchestrator kind of thinks like. So it breaks it down. So if I was going to build a brand new production system, I would work with the orchestrator to build that project plan and what each one of those phases and tasks will look like. And then the orchestrator will compile that into Neo4j with the right data modeling, and then start, assigning roles, handoffs, and all these things. And the orchestration needed to like break it down. And then each task gets governance. So, and then once they start running, the orchestrator. So the orchestrator has its own guards. It'll have like, in order for it to change a task from pending to active, it'll also have to complete the checkpoints to make sure, hey, did you only put context with, is the context more than 5K characters? Do you have the right role? Is the context bundle attached? Is the handoff attached? All these different things that the orchestrator must do in order to provide a perfect context bundle. And then once it changed to active, the executor picks it up, performs the actions that the orchestrator wanted to do, and then goes through its own set of checkpoints and guards in order to go to the transition state, which is ready for governor. And then after that, the reviewer comes in, that is anti-bias LLM, reviews the work, kind of looks for things that the agent was lying about, validates the Git, validates all the PRs to make sure that like, hey, what the agent said it did, it actually did. And then the biggest thing here is like, You never let the agent score 1 to 100 because they'll always give themselves 100. Like they're so biased towards you. You have to drop it. And what I've been iterating on for a while is like, I dropped it to 1 out of 85. So 85 is just like, hey, you completed exactly the work that was given to you in the bundle. And 85 to 90 is like, you went above and beyond. So you built, found an additional bug and actually solved it and added to there. So like you kind of incentivize the agents to go a little bit higher. That took me a while to learn. Like for a while, I was realizing that they were just all doing 95s and 94s, but nothing was still the same thing. Like, so there's a lot of iterations and testings and I guess scar tissue of doing this loop like a billion times. And then lastly,
it's funny how they then in the end, you shouldn't humanize all of this, but then you cannot really avoid it because it's like back in school or at as a manager of teams, you're like, okay, you cannot do the 100 because nobody's doing the 100, so you have to arbitrarily get a feeling of, okay, yeah, this is what I want. This is like a pass is 85. So it's very funny.
And it's even now, like I recommend everyone like take the scoring and make it your own, because even 85, they're still biased. Like there's ways that you can go about it. One of the things that I've been really testing in production is like two governors that run at the same time. One that's like normal, and then one that's like kind of like an anti negative and then positive kind of personalities, and then the difference. And if it's bigger than 10 point difference, then that becomes like a rework. So there's like many ways that you can make this governor your own per se. And I like highly recommend, like in the next slide, I'll show you a little bit more about the scoring, but I highly recommend making the scoring your own and testing the scoring, because that is really what I've learned is to stop some of the bias.
Cool.
Yeah, so a little bit more about the scoring. So the governor agent has its own kind of scoring mechanism built into to how his personality, his policy, when he gets compiled at runtime, has these different types of built into the prompt. So basically he's got his compliance. So 1 to 85 is just like you did exactly what the orchestrator laid out in the handoff, perfect to a T. There's no misses. It's all of the state and architecture that you're supposed to do to keep like everything aligned with the data in your knowledge base is perfect. Like you just checked all the checkpoints and everything was there. That's like perfect work. Nothing like outside of the ordinary, exactly what was told. And then it breaks down from like completion, what was the core execution that was completed. So 1 out of 20. Code quality, it really looks into code quality as well. So some of the things that we all know is LLMs like to write a lot of code. So I have a lot of, mechanisms to hinder that. So elegantly write code, only write enough lines to like make it. So that's that code quality, as well as documentation. Like when they fill out their self-review and their task and everything that's needed, are they lying, basically? And the governor directly trace what the agent said and find the point that was made. And that's what the governor does. It's just like making sure that the agents are actually saying exactly what they're saying and that everything is validated. And they also test what they just built to make sure that their statements are correct.
Cool. Yeah. Nice.
And then high level, I think the data model is always kind of important here. And one of the things here is to notice is tasks are kind of like the main way that this works in general. Tasks are like the unique node that's the most important. It's where all of the work happens. It's where the footer, where the agents communicate as well. It's also got all the status changes. So whenever like an agent moves and progresses, the agent pick up the same task and keep progressing and making that task more deeper and complete as it progresses forward. It's got a role. So roles are, assigned to tasks created by the handoffs as well. just basically the overall data model. And then if you notice in the top right, that's just showing what happens when a governor, fails and rejects the review and scores it like a 15, which I'll show in the demo. The next agent will complete its work, submit another governor review, and then it'll pass at like a 90, so that you'll see that the key here, especially for like building your knowledge map, is like not to delete nodes or like overwrite nodes that are remaining. One key thing that I found was like supersede the nodes, because then the agents can actually understand like, holy shit, like this one task had like four revisions. Why did that happen? And you start thinking about, oh, okay, so like agents can make that revision process like a little bit more streamlined and get better with the work. So like the supersedes, like I can't tell you how critical of a learning that was for me, because I was realizing that like it wasn't getting better.
But I can totally see that. I mean, imagine, right? I mean, if you have tasks that are in principle a little bit similar, if you have this and keep it in your graph, then if something comes up that is taking into account, okay, previously we tried these 4 approaches and they failed, but the outcome is similar, or the task I'm asking now is similar to a previous outcome I have already completed. So let's not do these 4 trials because they didn't work before. So let's jump right the queue and go right to the final task or the final step or the final process that worked well. So you can that ultimately saves you time and money.
Yeah, and not only that, you can to put one more point there, Alex, is you can put limits on rework. So if, let's say, you get into a loop where the agents do 3 reworks in one task, really what that should do is like, hey, there's something wrong here.
Yeah, true. Also a good point. Yeah.
Block the task, put it back to the orchestrator and have them do deep research to figure out what happened here, and then kind of optimize the next, like supersede the handoff, supersede the task, and create a new one in order to like get to where your goal is. And if you start thinking of like that way in data and nodes and stuff like that, and start doing this and forcing your agents, I think, to work in this way and track all their stuff, pretty soon your database becomes really, really really ripe with a ton of really good work knowledge. Let me see what's next. Okay, cool. Demo.
Nice.
Yeah, so first one, kind of show you the first handoff. So taking one of the handoffs from one of the projects that I have and running it through what the cold start looks like. And then also, this is the governor run. So it'll be the governor reviewing a previous work of an architect reviewing some great things about Neo4j and why it's great for multi-agent orchestration.
Sounds good.
Awesome. So can everyone see this? Great. Typical Claude. The reason, I'll tell you guys this, the reason that I'm on desktop and not using VS Code or Claude Code attachments is purely for multi-agent orchestration. This UI interface, as well as cursor and all these different things, is really good for me to be able to run 10 to 12 agents simultaneously and be able to see and get into it. So that was one thing that I really learned, and maybe it might be a little bit different for people out there. But so the first one I'll do, if you notice, this is my orchestrator agent pulled the demo project out of my repo, out of my knowledge base. We've got our handoff, which is a node in Neo4j, the perfect handoff. And we're just going to copy and paste this into a new session. This is really high. I'm going to go down.
So this is basically looking at where you stopped yesterday with your work to catch you up again, or catch the agents up again, and then to give you basically a prepared start for whatever comes today.
Yeah. So basically the handoff is kind of the first step for the agent to, hey, I got to understand who I am, and what I'm doing. So it's got its relationships, its identity bundle there. So it's understanding, hey, what are my handoffs? What policies are associated to me? So like, what can I do? What can it do? So you can't execute, you do not plan, you do not fix, you only validate. You are the governor, the incorruptible gatekeeper, like all this stuff. And below it's kind of telling about like what its governor, so its scoring matrix is, how it works, as well as the let's see if this is one. So quite a bit less. And the goal being that like, so, and then all the tools. So I've got my tools actually in Neo4j as its own node. So it pulls like what tools are associated to what agent at time at cold start. So the governor gets its own set of tools, what to run through the MCP, excuse me. And then it starts to, so that's just its identity.
Yep.
What it's asking. And then what it's doing now is really pulling its context bundle. So what's the work that it has to provide? And if you notice, the context bundle is limited at 50,000 characters to really keep your context light.
Okay. Yeah.
As well as policy. So it'll pull its scoring rubric, how to score the policy node from Neo4j. And this is all the governor just getting the perfect context it needs for this specific task to review the agent's work. And it's all decisions and nodes and edges in Neo4j that all start from one task node. So one compiled. And after this runs and goes through, I'll show you the data landscape in Bloom in Aura. So as this is running, it'll pull the context bundle, it'll start to go, and then it'll review all the agent's work that it performed from that task, check it, and then score it on its scoring matrix. While this is running, I mean, I can definitely answer questions.
I just wanted to say, like, maybe let's let this run and answer a couple of questions. There's one from Matthew. Matthew asks, what happens if a guard agent does the wrong thing? I don't know if you will show this, or if this is something like that happens.
Oh, like if the guard, definitely. So the guard does a wrong thing. It's been a while since one of my agents, to be honest, have done the wrong thing because of this context bundle. So when you focus on the relationship between handoff to role to policy and to task, and you compile those like I did with my handoff ID, that it's really hard for the agent to complete the work. Now, you might see some stuff where in the past, if you didn't have all of the duplication or layer on top and understanding if agents are creating similar nodes, absolutely. But if you build that into a lot of the MCP tool calls, like if they try to create a task, there's like a layer in the tool call that's like, hey, if there's a similar semantic edge to this, block this task and ask the owner, like, hey, looks like there's a duplicate task. Let me so all these governance steps that you do with just like scar tissue, honestly.
But that's also a nice thing, right? I mean, you don't know if you have done something. Well, you might know, but if it's like multiple people are working on this, and maybe somebody asks for something that has already been completed, you can say, hey, but wait a moment, we've done this before. We don't have to do it again. Here's what this was.
Exactly. So it's like think about it like we've talked about parts of the pieces like memory, RAG, embeddings, but what if you had every single piece from like the start in the beginning in one Aura database? And when I say this is, I don't know, it's maybe like a little bit outlandish, but I haven't had to use anything besides Aura to do all this. So like when it comes to cold start handoffs, context bundles, just Aura, governance, Aura with Python and script and IDE. And then I just work from my IDE like this, just working and burning down projects that are breakdown by like project phases and tasks. My agents run. Yeah.
That's really cool.
So you'll see like, oh, go ahead, Alex.
Let's look what happens.
So if you notice, it read through basically all the work. It brought the reports that the agent created before from its previous task. It read through that, and then it started scoring. So max, subtotal, base score. Realized that scored itself a 20 out of 85.
Yeah. That's not so good.
So not good. It rejected. So now it's working. So it's working through the check guards right now. So if you look through the transition task, the governor's now it's using the transition engine, which is in the repo, to, hey, I want to transition the status from ready to governor to rework. And it tried to transition the task. It pulled it. It said, hey, you actually passed. Everything's ready in the checkpoints. You can transition the task now.
Mm-hmm.
And then it transitions the task back to active and creates a task ID and a handoff for the agent to rework. And then you just go like this. And this is how I do. Boom. And that's my new, so that's the rework. So now the governor checked the work, failed the work, created a handoff and a task to the same node, has the next agent fill in the blanks of what the agent.
I see. Okay. Yeah.
Right.
Yeah.
And now this agent is going to go through. This is a revision request.
I understand. Okay. Yeah. Cool.
Yeah.
And now it sees if it can fix it this time around. Yeah.
Exactly. So, and that's the kind of crazy thing is like, now when you're thinking about this, if you have this governance, you don't have to use these frontier models, right? You can use Haiku, you can use any type of model because you have this layer here. So if you have 3 reworks, it could be a lot cheaper than using Opus 4.8 to do like one task completion. That might be like perfect and excellent, but like 3 Haikus might be like a fraction of the cost, even if it reworks 3 times. So like you kind of start to think in these models of like what model completes work the best, cheapest.
Or you could potentially, even if you have the hardware access, you could run it locally and just use a local model.
That's the crazy part is like when I started doing this, I started to realize, okay, what if this is really just physics? Like it's inertia of the agents trying to push the task, the compute, like one status to the other. So if they're just doing that, right, and you had a way to trigger an LLM call from Aura, local model, on-prem, no cloud, no nothing. You just have Aura, an IDE on top of this and a local model. You're good. Like for my like sensitive stuff, like my financial advisor.
Yeah, of course. Yes.
I have my own little what I call Aura backend agent OS thing for my own financial stuff.
Yeah, totally. Yeah, that makes a lot of sense.
So look at it. This next agent, the execution agent, now transitioned from active back to ready to governor, completed the previous work that maybe the agent didn't complete, and then we're going to give it back to the governor to rework, to review the rework per se, and rework that. Cool thing here. Oh, go ahead.
Yeah, well, this is running. Maybe we do one more question. They came in from Ravid. Ravid asks, and I think you touched on this. Are these guards just for text?
Are these guards just for text? No, they can be for anything. So let me show you a little bit. Let me go to the end. So you can use them for anything. So they're not only text, so text when it comes to one of the things that really struggles with agents, which is they can blow up nodes with how much context they want to put in there. They might just like throw a million characters. Like when I first started doing this, that was like a real big issue. Okay. So that like you start to realize like these guards that I'm putting in here are stuff that agents were tending to do that was breaking my state per se. Yeah. So I'm trying to lock them down so they no longer can do that anymore. So like, is the task schema valid? Is the token safety? So is the content less than 4K tokens before the orchestrator passes it off? Does it have a bundle? Is the cost of this proposed task under the roles budget that you can put in Neo4j? Executor guard. So is there a deploy rollback plan in the task of like, what does the deploy? So you're forcing the agents before they can transition to stack the transition that you must have all these items here. is mostly what I'm training. So it's not just text. Like you can actually sync with like Git and pull in the actual code logic and stuff like that. Like I have done to like so the governor can find exactly what's been made and stuff.
Cool. Okay.
Let's see if this one's still running. Okay, cool.
Running. Okay, then we do one more question from Matthew. Yeah. Matthew asks, what have you found is the relationship between rules and guards to check alignment with the rules?
Yeah, rules and guards. I would say think of them as a little bit different. So rules and guards. So rules, I would say, and policies are more agent personality. So like I had GCP agent has a policy that, you know, can only read, you know, BigQuery and perform that. And like, that's more of like the rules and policies associated to each role and personality. Mm-hmm. The guards are kind of the things that are outside of that unique personality side. They're like, doesn't matter the personality, doesn't matter the context, it doesn't matter the task. This always happens every single time an agent tries to perform a task in my architecture. So I would think about it less about rules, more like stuff that you need the agent to do in order to accurately provide multi-step, you know, orchestration or handoffs and stuff like that. And then as well as like validating exactly what the agent did. So it's more like checkpoints in order to transition the status to keep your state and architecture aligned, where rules are more context nodes that are compiled into a personality or role in order to for the agent to understand who it is, what to do, and what not to do.
Okay.
Hopefully I answered that. Okay. Great. I can show a little bit about data landscape in here. Yep. This is exactly the project that we have running right now. So if you'll see here, we've got the project. What is it? Keys. What are the notes? But down here is the real task. So this is the task that we were running right away. So you can see the task node has what the objectives are, investigations, deliverable, acceptance, costs, kind of all these different metrics that you can make your own and make them better and adjust to them.
Yeah.
But really, it's you know, what we know agents do well, which is empty files. And how do we as humans also understand what agents doing? Empty files. Cool. So if you, let's go back to here. Okay, cool. So now if you notice, the second agent came through.
Yeah.
Did it, passed the barrier, 90 out of 100. And the cool thing about this is, like, I showed you one agent run in the last kind of demo that I know we've got 5 minutes left is show you what happens and how this works with multi-agent. So as you guys know, I'm just going.
Okay, so you just execute.
That's it.
Okay, kick off.
I'm officially just copy and pasting for the rest of my life. Yeah, but the next, in my production one, there you can, so I'll have a demo in the future, but if you guys haven't checked out what change data capture can do for Neo4j and business critical, using change data capture when you transition these stages from active can call an LLM, an Anthropic SDK or anything, and compile the exact same handoff to the agent and run. So really all you need to use is change data capture and an API to Anthropic, and you've got multi-agent orchestration on top of your database.
Wow, that's pretty cool.
Yeah, that'll be a future demo.
Yes, looking forward to that. There's one more question from Varun. Varun asks, how do you check if the correct context is being propagated in each step to answer the original question correctly? So how do you check if the context is sufficient also?
Yeah, sure. Let's say you could also just go like this. if you're not familiar and you don't want to jump into Aura, I'm just going to ask. And what it'll do is it'll pull the exact content into chat so that you can see exactly what the agent was provided.
Okay. Yeah.
See, my policy is compiled. Identity bundle. And then the work. So like what was the actual work that was given to, so you've got the identity, you've got the context, you've got exactly what was given to the agent here, and then the footer, which is kind of like the communication between agents is what I learned.
Okay.
Yeah. So I would just do that.
Yeah.
LLMs are smart.
Yeah, exactly.
Work with them. That's what maybe that's a non-technical with me is I just had to force my way to just ask LLMs a ton of questions all the time, and iterate and test. So these are all going to run. They're going to go through the same loop. So every single agent performs the same actions over and over and over. But the only thing that difference is the one context that's in the node of what they want to do.
I see.
Yeah. That's it.
Very nice. There's one more extension, I guess, to Matthew's question. He says the term rule was a bit too vague. He was thinking about code style and such.
Yeah. So mostly the one in the repo that I have here, I'll put it, this is really just honestly the custom guard code
as well.
And you can reference so they're in the repo. There's a state machine. There's a transition guard. Definitely share that. That's all in the repo. And what you can do is just, either just have an LLM go, hey, I want to use this repo, pull it into whatever I'm using, and then make it mine. But you can really update these register these guards with whatever the guards want to be. And if you'll notice, there's like fix hints. So if they don't hit, like require self-review greater than 7 before submission. So guard context, if it fails, what's the guard result? That's kind of like the unique pass back to the agent. They know how to fix the guard. That's kind of the little quick code block that you can make your own. And then in the state machine, which is like what the agent runs in order to transition the state to the next stage, it'll call the ID guards and it'll either pass based on this logic. And if it doesn't pass, it'll fail back to the agent and they'll rework. So this is a very rudimentary part of it, but all of it's in the repo. So I would definitely check it out.
Cool. Yeah, that's a good point. I also put the repo link in the chat. It's also in the YouTube video description. So you can look at that if you want. I think that's probably also a good way of saying, maybe you do the 5 things first.
No, I was just going to say
let's do that. Yep.
No, last thing I was going to say, Alex, is just like 5 things you take this away from. Gate the work, gate all agent work, and then make sure that you keep the receipt of all the work that's in your knowledge base, because the more work you put into Neo4j or Aura and build those relationships, the better your agents are going to be, no matter how you build this. So just force yourself, like one kind of thing, just force yourself to try to use these LLMs to do as much as your daily work as you can. And then put it into a Neo4j and model it. And then all of a sudden you have a knowledge base of what your work looks like.
Absolutely. Cool. And the library is, as you put in number 5, library is available, library is there. If people, want to try it, please do so. If people want to have, conversations with you, or if they have some, I don't know, issues or requests or just, open points, then I guess GitHub is a good point. Also, LinkedIn, I guess, or email. Yeah.
Anytime. Happy to help. And then also, if I can be of any help, reach out anytime.
Super. Cool. I think this was very insightful, very cool session. Thank you very much, Julian. Thank you for building all of this. Thank you for making it available. I'd love to see what you know, if any of you guys are interested in this topic. If you adopt it, if you have success with it, if you maybe, you know, make it yours, like Julian suggested. You know, everything is up for discussion or for personalization and customization these days. So I think it's good. It's a good baseline. Let's hear it. That would be great to see. If you are interested in hearing more, I would like to invite you to the 2nd of July Graph Talk Pharma and Life Sciences live stream event that's taking place all day long, basically. Here in Munich, but we stream it out online on YouTube, so you can slot this in your day and watch very influential voices from the life sciences, pharma, and healthcare industry across the globe who share their stories, how they build and what they use Neo4j, AI, and all of this together. So that should be interesting. Obviously, notes, call for papers has been closed, but if you want to keep up to date, you can already register and get the latest on what's coming up, and Road to Notes will be there as well. So that should be fun. And if you want to build yourself something like what Julian just showed, or something more with graphs, check out our Graph Academy. There's an amazing platform to learn. Aura Free is a great place to start. Julian mentioned it, to build and to get started with the whole tool set that is now available to you with document intelligence, Aura agents. Makes it as easy as possible for you to get started and get building. And if you have questions, if anything is unclear, neo4j.com/developer is the place to go and see all the resources available. But probably you just use Claude and just, you know, let it let it run.
Exactly.
Yeah. Cool. I think with that, we're at the end. Thank you very much again for watching. Thank you very much, Julian, for the session today and for the demo. And I'll see you on the 2nd. Hopefully, if not, then somewhere else on an event, on a conference or a meetup. And yeah, take care, everybody, and don't sweat too much if you're in Europe.
Thank you all.